You are an astronomer. Your eyes are always on the skies. As usual, one morning you find yourself at the radio telescope, ready to review the data collected overnight. You don't expect to find anything out of the ordinary, of course. But as you look, and then look again, something seems different. You can't shake the feeling that there must be some mistake. This just isn't normal. You notify the other astronomers you're in regular contact with. They don't believe you at first. They laugh it off. But you persist, trying to convince them. Then, as you're about to take another look, your phone rings. It's your friend who was laughing earlier, sounding quite worried. You were right, they say. You were right. This isn't normal. And then the whole world starts to shake. A sense of panic spreads. Newspapers, television stations, all broadcasting the same news. There's a black hole in our solar system. A black hole of unknown origin is somewhere in our system right now. And we don't yet know what this means. So, what if we woke up one morning and received this news? What would it mean if a black hole entered our system unexpectedly? Let's explore what might happen. But first, let's dispel some concerns. With today's technology and our current knowledge, the likelihood of us suddenly noticing a black hole entering our solar system is extremely low. Not zero, of course, but very, very low. I think I've eased some concerns there. Anyway, back to the point. Let's begin with a thought experiment. Today, if a black hole were to knock on our solar system's door, what would await us? First, let's understand what we mean by a black hole. Most black holes form as a result of stars at least 10 times more massive than our sun exhausting their fuel. When this happens, i.e., when such a star's fuel is depleted, there isn't enough temperature and pressure to sustain its outer layers. As a result, during a supernova event, the outer layers are ejected into space in a massive explosion, leaving behind the core. This core then begins to collapse under its own gravity. If the mass of the core is 2 to 3 times that of the sun, the collapse is unstoppable and continues towards a point, marking the birth of a black hole. In its simplest form, what emerges is, I can't even call it a hole, but rather a pit, extending towards infinity, a result of almost infinite density. This incredible density creates a gravitational pull so strong that not even light can escape, and anything unable to surpass the speed of light cannot escape this gravitational force. And we know that nothing can surpass the speed of light. We're talking about such an entity, and the entry of such an entity into our solar system is certainly not good news. The first thing we'll notice is changes in the orbits of objects in our system. Institutions like NASA constantly monitor the orbits of thousands of bodies, including planets, meteors, comets, and so on. The routes they follow can be calculated for very long periods. Any deviation in these calculations would immediately raise suspicion. Even if the black hole were hundreds of thousands of times farther away from us than the distance between our sun and Earth, we would still notice it. Now, let's say the black hole is gradually entering the system. It would pass through the majority of our solar system's outskirts, known as the Oort cloud, composed mostly of icy bodies such as millions of asteroids, comets, and similar objects. Initially, as it passes through here, its incredible gravitational force would create significant chaos among these various sized objects. Remember, all objects approaching a black hole unforgettable singularity. The majority of them will orbit around the event horizon at speeds close to the speed of light before being flung out into space at the same speed. So the black hole will start hurling thousands, even tens of thousands of metaphors to every corner of the solar system. It's quite possible that some of these objects will hit planets, including us. Of course, if we were to see these objects embarking on their new journey, and even if they were moving at a speed of 50,000 kilometers per hour, it would still take about 20,000 years for them to reach us. But for now, let's set aside these calculations. Let's continue, assuming we realize this too late. Actually, this is the good scenario. If the black hole were to just pass through this cloud and then leave the system, the biggest change we would notice is an increase in the number of asteroids in the system. Even a single asteroid could be enough to wipe out life on Earth. But still, considering the effects we'll discuss shortly, this would be a favorable scenario. Besides, NASA is preparing for the asteroid threat with the DART mission. On one hand, maybe we would have a chance in this situation, or at worst, we would have more than 20,000 years to find a new planet. Or maybe we would stop fighting with each other to prepare for extinction. Who knows? Continuing, of course, we could directly observe the chaos in the Oort cloud caused by other objects. But we wouldn't be able to see the thing causing this chaos directly, the black hole. No matter how we look at it, we wouldn't see what's there. We would be watching the chaos created by an invisible monster coming towards us, like a horror movie. The way to track this black hole would, of course, be its ability to magnify the light from the stars or other objects behind it, in addition to the effect it creates around it. Do you know about gravitational lensing? However, this effect would not be very significant until the black hole gets quite close to us. When it approaches the asteroid belt between Mars and Jupiter, the bending effect will increase so much that we would feel like we're looking at an optical illusion. And of course, by the time the black hole leaves the outer solar system behind, after swallowing or disrupting some of the other planets and completely altering their orbits. When it gets this close, we would start seeing this monster clearly. And of course, at this point, the rotation and orbit of the Earth would experience significant deviations. Of course, we should also discuss what could happen as it passes by Jupiter. A giant like Jupiter wouldn't be an easy target. Most likely, a war among Titans would begin. Yes, most likely Jupiter, in terms of size, would be much larger than our star, but the mass of a black hole would be thousands of times greater. Of course, we would witness the inevitable victory of the black hole. During this time, we would observe Jupiter's gases slowly being collected in the accretion disk of the black hole, reaching incredible speeds and turning into a spectacular visual display due to the heat generated by friction. From this point on, great troubles would begin for our planet. First, consider the tides caused by our moon. Even a small object like the moon causes a movement in the liquids of our planet. Now imagine the billions of times more powerful version of this. Think about the changes in underground waters and magma. So, when a black hole approaches us, the first effect we would observe is an incredible increase in volcanic activities. We would see supervolcanoes like Yellowstone erupting one after another. We're talking about an unprecedented or rarely seen crazy volcanic activity in human history, or even in Earth's history. This alone would have a devastating impact. Of course, our orbit would also be completely altered. There are two possibilities. Either we would be pulled towards the sun or away from the sun. In both of these scenarios, dramatic climate changes would occur. So from this point on, whether the black hole captures us or not, there would hardly be any chance left for life on Earth long before that. When the black hole finishes with us and starts moving towards the sun, that's when the real boss fight begins. Our sun alone accounts for 99.9% of the mass in the solar system, so they start exerting a very strong gravitational pull on each other. As the black hole approaches the sun, it slowly pulls the gas from the sun. Meanwhile, on Earth, where there is no longer any life, it begins to be drawn into this battle and, under the influence of this duo, would be shattered and eventually vanish into the black hole and into oblivion, humanity included. Everything that happened would be as if it had never existed. We could have talked about a similar fate for other planets as well, or they could have been flung into the void of space, surviving as rogue planets, alone in the depths of the cosmos without their sun. Our sun, on the other hand, would most likely be slowly but surely consumed by the black hole. So, if a black hole were to enter our solar system, it wouldn't lead to good things. But, as I mentioned earlier, the good news is that the likelihood of this happening is very low. The most important reason for this is the position of our solar system. We are relatively close to the outer edge of our galaxy. The density of black holes is generally higher towards the center of galaxies. and black holes mostly wander aimlessly within galaxies like rogue mines. There are usually very large distances between them. So, for now, you are safe. At least, the likelihood of a black hole being the cause of our demise is much lower than other possibilities. Unless we get our act together before the cosmos gets to us, it seems like nothing else will bring about our end but ourselves.